What we saw with Macondo is when something goes wrong in a very bad way, it not only impacts the people on that platform and the company involved, but it also has this huge impact that spreads around the Gulf. The Gulf Research Program was set up as part of the criminal settlement between BP and Transocean, two of the parties deemed responsible for the Macondo oil spill in the Gulf in 2010. Out of that settlement, they allocated from the two companies a total of $500 million to be spent over a period of 30 years on science-based research for the Gulf of Mexico. As a research program, it's trying to take this broad, holistic view at the full life cycle of energy development and making it as reasonably safe as is practicable.
The largest feature, the largest dynamic feature in the Gulf of Mexico is the loop current. The Academy decided that we should do a study, and the study would say what kind of research and observations should be made to improve the understanding of the loop current and our ability to predict its movements.
It is moving at least half of the water of the Gulf of Mexico at any time.
It's pretty deep and it's pretty warm. And every once in a while, it spins off an eddy, and that eddy will migrate across the Gulf, sort of towards Texas and the Mexico border.
If you don't understand the loop current, you're going to have a hard time understanding what's happening in the Gulf of Mexico.
Our hurricanes feed off of it. Fisheries respond to it. It can tear oil production platforms from their moorings.
God forbid there's some kind of an accident and there's a spill. If you have a pretty good loop current prediction, you'll be able to predict where the oil goes, and that will be important.
We can understand a lot about what's happening under the water by measuring what's happening at the surface.
And so these are the data from the ones I'm operating right now?
Our project involves putting 2 radar systems on 2 offshore oil platforms in deep water of the Gulf. And so these radar systems will measure currents at the surface of the ocean out to about 200 kilometers away from the platforms. We're going to have measurements in the deep Gulf of Mexico that we haven't had before. If we know more about the loop current, we can make better decisions for offshore oil and gas operations, for shipping, for tourism, for hurricane evacuations, and for ecological management.
So you guys are going to be taking this old string we're pulling out, moving it up to the front, stacking it up.
And our project is on the key safety issue for drilling in offshore oil and gas. And that is, when you get gas in the riser, that's a precursor to creating a blowout situation similar to those that have occurred like BP Macondo. We can actually inject gas in a 5,000-foot deep well to simulate the gas in the riser. We're also looking at how the bubbles go in and out of solution at different pressures and temperatures.
I think we're pulled like 20, 30 joints of the 2 3/8.
Industry is very much hungry for this kind of data to create models to enhance their detection and control systems for preventing a blowout from happening.
We held a series of workshops to focus on oil spill response and recovery. One of the major things with oil spills is there's a lot of mistrust, not just from the industry or whoever caused the oil spill, but amongst individuals within that same community, mistrust amongst fishing industry, tourism industry, and others. The response community has a set process that they use to respond to oil spills, but a lot of times people who are not part of the response world aren't aware of what that process is and why things are done or not done. So we're trying to couple the non-response world with the response world and jointly better prepare these communities for future spills. Not during a spill, but before a spill. If you're shaking hands after a spill has occurred, it's too late. We need to have those relationships built on the front end.
Our project was focused on studying the human factors and the complexities of the human behavior in the drilling operation, how they react to distraction, fatigue, and stress management.
You can bring in the next part while I take the top drive up again.
Okay, thank you.
According to the research on eye tracking, if you're able to track their eye movement, we are able to evaluate if they are distracted or not. It's a lot of data they deal with, and they have to make a decision quick. What we're proposing is real-time eye tracking system. Everybody who is working on a rig have this type of glasses on, so if they get distracted or something, that alarm system kicks in and helps for the decision makers to prevent any major incident.
Workers have the right and the responsibility to stop work when they believe something is not being done in a safe and prudent manner.
When we start talking about stop work authority and shutting down an operation that's $1 million a day or $600 a minute, it's terrifying for everybody.
The GRP funded a workshop on worker empowerment. While they're being told that they have this responsibility and ability to stop work when they believe it's unsafe, do they really feel comfortable doing that?
The biggest problem that we have with our existing systems and even the existing culture, it's not designed to generate trust between the regulator and the operator. And that is distinctly different from the way the FAA and the aviation industry act and work. I presented the whole entire concept of what if we could use the FAA model in the offshore regulatory and operational environment. There'd be some challenges implementing it, but when you learn about it, it's like, man, why aren't we doing this?
The idea of the Gulf Research Program is this chance to take this very broad, holistic view of oil system safety. The fact that there is a lot of economic value generated by oil and gas means we're going to continue to do it. It's going to continue to happen. And given that it's going to continue to happen, it has to be managed as safely as possible.